Thanks for coming to the talk. I appreciate that. Today we are going to talk about reactive microservices of course, in Java. Why not, right? Using Spring, JHipster, and we are going to deploy that to Kubernetes. I'll try to do a good demo, hoping that the time would be sufficient, so I need to go fast. A little bit about myself. I'm Deepu K. Shashidharan. I'm the co-lead of a small project called JHipster. I'm a Java champion. I have created a bunch of open source tools like Kdash, which is a Kubernetes dashboard, JDL Studio, and so on. I work as a developer advocate for Okta. My focus is more on DevOps, Java, Rust, and stuff like that. OS aficionado, have written a book. I frequently write about tech stuff that I'm interested in on my blog, on the Okta developer blog, etc. So do check these out if you like this. You can follow me on Twitter if you like to get updates about the content that I write. So let's proceed. So what is reactive programming? Just for the uninitiated, I hope most of you know. How many of you actually don't know what reactive programming is? Just so that there's no shame in it. I didn't know until yesterday. Yeah. So reactive programming is basically a programming paradigm where you're going to work with a lot of asynchronous data, basically streams, which are nothing but events ordered in time. So you don't have to, like in your traditional imperative way, you don't have to respond for request to response. You don't do one-to-one. You can get a request and you can process that over time depending on the stream that you're processing. So basically handling events ordered in time. So that's about it. Of course, like any other paradigm, there are pros and cons of reactive programming as well. So on the pro side, reactive streams are easier to compose and manipulate. You can build actually very complex and highly interactive UX using reactive streams. A lot of highly interactive applications these days might have a reactive backend, so there are so much interactions going on. You can avoid callback hells with reactive programming. You don't have to, rely on callbacks anymore because you can register to certain events and just handle those, that kind of way. If you are familiar with observables, it's the same thing. And of course, if you have a lot of asynchronous data, or if you're handling a lot of huge data like video, audio, streaming data files, or log processing, or machine learning applications where you're handling a lot of data, these kind of things can actually make use of reactive programming, and this can be these kind of systems can be much better with reactive programming than your traditional imperative programming. Of course, on the negatives, these reactive programming is much more harder. It's not as simple as imperative. It's much more harder to learn, much more complex to implement. It is also much more memory intensive on the system itself. They're harder to debug. Have you ever tried debugging a reactive distributed system? Yeah, that will be a separate journey on its own. Another important thing to consider is it has been around for many years now, it's still not as mature as your normal MVC stuff that you do. You'll find it hard to find educational material. You'll find hard to get answers from community on Stack Overflow, for example. So community help overall will be much less compared to your traditional MVC programming. And on the Java side of things, these are the three major projects that you need to look into. So if you're doing simple reactive stuff, maybe the Flow API introduced in Java 9 is good enough. It has a simple implementation. It provides most of the basic interfaces that are required for reactive programming, so you can get away with that for simple stuff. But if you are considering more complex implementations, more complex projects, then probably Java Flow API is not sufficient. Then you would have to consider either RxJava, which is quite popular, or Project Reactor. So both are quite similar, slightly different implementation. They have similar concepts. Like this has, RxJava is more observable based, whereas Project Reactor, works with fluxes and monos and stuff like that. So Spring uses Project Reactor, so that is what we are going to, see today as well. So let's also have I'm going to do a little bit of quick introductions before I go into the actual demo and stuff like that. So on the Spring side of things, we do have a full-fledged reactive stack now. It has been in the works for a few years, and now I think it's quite complete. So here you can compare the reactive stack to the traditional servlet stack. So the reactive stack is, of course, built on top of Spring Webflux, on top of Netty, on top of Spring data repositories, which includes RTDBC, R2DBC for SQL stuff, and of course, non-SQL databases like Mongo, Cassandra, they all support reactive already. For SQL, it took some time, but with R2DBC, it's also, traditionally SQL is not very reactive, but it's there, it's somewhat there. So Spring Security also has a reactive implementation now. So the stack is quite complete. You can see side by side how they differ, and most of the serverless containers these days also support this. And the main aspect of the reactive stack would be, of course, Spring Webflux. So it is equivalent of Spring MVC when it comes to the reactive side. Though they have some things in common, like the annotations and stuff. They have reactive clients. They can run in Tomcat, Jetty, and Undertow, for example. These are the common part. But they differ vastly. For example, Spring MVC is very imperative. It is one request per thread model still. It is blocking. Whereas Spring Webflux is more functional. It has functional endpoints. It uses a concurrent event loop so that there are your requests are non-blocking. So it's non-blocking. And of course, it's on top of Netty. So they're more different than they are alike. So a small example for Spring MVC. So this is something that JHipster generates for using the traditional Spring MVC, using Spring MVC. So as you can see here, we are just saving an entity and returning a response entity for something called product here. And for the same, if we generate, using JHipster, if we generate it with React, then we will do the same thing. Underneath, it will still save the entity, but this time using R2DBC, and it will return the result using a Project Reactor's mono interface, so which is a defined stream. So a mono is a defined stream, and Flux is an undefined stream. So Flux can be 0 to n, whereas mono is 0 or 1. That's it. So this is not that interesting because this doesn't have a lot of advantages that reactive actually offers, because this is performance-wise or whatever, it will be exactly same as what you will do in MVC. The real benefits and everything starts when you actually start using more undefined data, like 0 to n streams. That is where you'll actually start seeing a lot of differences. Even from even for the mono ones, for certain use cases, this can be more beneficial because with reactive streams, you can do a lot of things with the streams. You can if you have used observables, you would have come across this. You can work on the streams. You can apply different transformations on the streams. So similarly, you can also, of course, you can do those things in traditional way as well. It's just handling data. But here, the interfaces are much better. They have more functional implementation. So if you're into functional programming, then you would really like the way how reactive programming is done as well with Project Reactor. A lot of functional stuff there. So do check that out if you're into functional programming. And the most important question, before we go into any paradigm, right? Do you actually need reactive programming? Absolutely not. That's my opinion. Because most of the times, imperative programming model is more than sufficient. This is like the same microservice argument. Do you actually need microservice, right? So similarly, you don't always need reactive programming. The only times you will actually see benefits of reactive programming is if you have a lot of asynchronous data, if you're handling a lot of streams. Of course, if your entire application is about audio-video processing, absolutely. Reactive programming is going to be beneficial for you. You will find it much more easier to handle and everything. Even considering all the negatives of reactive programming, it'd still be worth it. But for a simple application, say for example, a simple shopping cart application or whatever, absolutely, you don't need reactive programming. Simple imperative programming is more than sufficient. So with that, let's get into some JHipster stuff. So how many of you are familiar with JHipster? Raise of hands, please. Oh, not bad. And how many of you have tried JHipster? Do you like it? Okay. Huh? Okay. I think it still has 50% of the code that I wrote. Slowly being replaced. I'm being phased out slowly, by my code at least. So. Okay, so I'm going to quickly summarize. So JHipster is one of the most popular rapid application development platform in the Java world. You can scaffold modern web applications with, like a modern React front end, or an Angular front end, or a Vue.js front end, or whatever you want. There are plugins to get Svelte, for example, all sort of stuff. You can build API-only applications with it, with just Spring MVC or reactive APIs. You can build microservices with full-fledged, config servers, your service registries, and all sort of stuff. You can build Istio applications with it, for example. You can scaffold CRUD entities. You can scaffold CI/CD for the application. You can scaffold Kubernetes configurations for application. Whatever you can, most of the things you can think of, JHipster can do it. So it's quite popular on Netflix. It has a pretty big user base. It's available either as a Node.js CLI that you can install and run commands, or you can also try it online at start.jhipster.tech. You can generate applications online and get it directly on your GitHub, or download it, whatever you prefer. So that's basically a summary of JHipster. And if you are thinking, for those who are not familiar, why JHipster? Because it's not just a run-of-the-mill scaffolding tool where you'll get a bunch of junk code, most like if you're using like OpenAPI generator, for example, most of the code you generate will be like a boilerplate, repetitions, and stuff like that. Whereas in JHipster, it will look very close to an application that you would code by hand. Of course, there will be some repetitions here and there, but the quality will be much more higher. The code quality is much more higher. Developer experience is going to be much more better. So we try to provide production-grade code, and you can look at the Sonar rating for that for an sample application. We try to do best practices on all combinations you select. Most of the times we try to get there, but sometimes we might miss something or the other. But most of the times we try to get that best practices out. Fully working CRUD applications out of the box, production-grade security, of course, and for most cases, you could get away with just doing business logic and UX, UX stuff. The other stuff would be there when you generate an application. So that's about JHipster. So let's move on to what we are going to do today. So today I'm going to generate a microservice architecture using JHipster, of course, reactive architecture. So JHipster can create many types of microservice architectures. It can create reactive ones, normal Spring MVC-based ones. You can use it with, you can create architectures using JHipster's own registry application that acts as a config server and your, microservice registry. Or you could use Consul, or you could use Istio if you are going to deploy it on Kubernetes. So there are multiple options. And this will be the architecture that I'm going to do today. I hope I have probably 30 minutes to demonstrate this. So we are going to have 4 applications, a gateway, which will have a Spring Cloud Gateway integrated into it. So the gateway is also going to handle authenticating. We are going to authenticate using OIDC and, of course, Okta. And 3 of the application is going to have a Postgres backend, and 1 application is going to have a MongoDB backend. I'm going to use JHipster registry. I can also do the same with Consul, not much difference. I'm going to go with JHipster registry here as a service discovery server and a config server. So, and we are going to deploy all this to Kubernetes using Google Cloud Platform. Before that, so Spring Cloud Gateway is something important in this mix. So Spring Cloud Gateway is responsible for forwarding security tokens. So when you make requests, it's going to redirect to say in this case Okta for authentication. And once it is authenticated, Spring Cloud Gateway is responsible for relaying that tokens to the microservices. Then the microservice validates those tokens to make sure that you're authenticated. So that's the authentication mechanism in this mix. And for that, Spring Cloud Gateway is quite important. And Spring Cloud Gateway is part of the Store Gateway that I showed in the previous picture. So that plays a major part in this architecture. And again, the question, do you need microservices? Most of the times, no. Most of the times, you don't need microservices. And probably from what we have learned in the probably last decade is that there was a phase when microservices were all the hype. Everyone wanted to build microservices. I think I have seen teams of 5 people building, 20, 30 microservices or even more. I was in a team of 3, 4 people building 6, 7 microservices at one point. So not always needed. Most of the times the monolith will do the job. So when in doubt, go with the monolith. So if you have a huge team, then maybe worth it. But for smaller teams, microservices can be more of a hassle than a boon. So keep those things in mind. So demo time. I'm going to, of course, as I said, I'm going to create an application and I'm going to deploy that to Google Cloud using Kubernetes. There are some prerequisites. You need a Kubernetes cluster. So I pre-created the cluster because from experience, I found that it's a bad idea to do that on stage for a presentation. It takes like 15 minutes there. I have to find ways to keep you entertained. So I have done this already, but if you want to try this, then this is the commands that I used. I created slightly bigger cluster. I think I can deploy this into a 2-node cluster with a N1 standard CPU, but sometimes doesn't go that well because it will be very tight. Of course, you can optimize the Kubernetes manifest further to make it work, but I'm not going to do all that because that will take much more time. I don't have that much time, so I'm going to go with a bigger cluster. So let me. Oh, I think I don't need this anymore. And nope. Yeah. Okay. So, oops, what happened? Oh, okay, still works. took a while. So this is the cluster that I have. Do I have connectivity? Yes, I have connectivity. I have already created the cluster. Let's take a look at the nodes. So I have 4 nodes running here on GKE. And if you look at the pods, so all the kube system stuff, there is nothing else here, just to be sure. Cool. So, oops, I don't need this anymore. Yes. So JHipster, when I spoke about JHipster, if you are creating applications, you can use the CLI to create applications. There is also something called JDL, which is JHipster's own domain language. Which is nothing but a simple DSL, very JPA-ish DSL, where you can define your application, you can define your entities, you can define how your deployment has to be. It's more like similar to how you do in Terraform kind of thing. So you can define all that in a file, and you can run a command to get everything generated. So I'm going to use that because it's much more faster to do and easier to demonstrate. So if you want to try this out, you can either run the command to download the file, or you can go to the link and get the file. It's on GitHub. You can refer to this documentation if you want to learn more about what JDL is and how it works and everything. So this is the file. This is how it looks like. Is it big enough? Should I make it bigger? Bigger. Is it enough? Is it enough? Okay. Cool. So this is how an application definition is going to look like. So I have an application called store, which is going to act as a gateway. And of course, bunch of standard stuff like your package name for the Java application. I'm going to use Eureka as a service discovery mechanism. I'm going to use OAuth2 for authentication, Postgres as a database. I'm going to use Hazelcast for cache, Gradle as build tool. Of course, when you specify any of these, there are multiple to choose from. For example, you can use Gradle or Maven. You can use Hazelcast, THCache, or Infinispan or whatever. You can use Postgres, MySQL, MongoDB, out of any database that JHipster supports. Client framework, similarly, you can use React, Vue, or Angular. And finally, I have enabled this flag so that the generated application is reactive. Of course, you don't have to do this for a gateway, because in JHipster, a gateway is by default reactive, because we use Spring Cloud gateway, which is reactive. So the gateway is by default reactive regardless of the architecture you choose. But for the microservices, and of course, I have put a small keyword here to say that all the entities also belong to the storeway, because we need the UI on the gateway. and the APIs on the microservices. We don't want UIs distributed. Of course, you can also do micro frontends with JHipster. If you specify that, then it's going to be separate UIs, which will be aggregated into your gateway. I'm not going to do that. So I have just defined this so that JHipster knows that this gateway should also generate the UIs for all the entities. And we have our microservices, as you can see, microservice application, similar stuff, Eureka or authentication and service discovery has to be same for all, for them to work together. The other stuff can be different. This could have been Mongo, for example, or Cassandra, doesn't matter. Build tool can be different. So server port, I want a different port. I don't want port conflicts. So by default is 8080, so I'm going with the different one. Here, reactive is required, otherwise this will be a standard MVC application. And then I'm mentioning what entities belongs to this microservice. Similarly, I'm defining another microservice called invoice. So this was called product and its entities and notification. As you can see here, it is MongoDB and no cache. And of course, its entity. And then I define the entities, which is very JPA-ish definitions. So you give a name, type, and if it is required or not, and some other validations that you can do. Like for example, required pattern validation, min, max, and these kind of validations. We have some we have entities. You can define enums that is used in entities. Like here, for example, enum types. You can define relationship between entities, very JPA-ish relationships, and of course, this is for if you need a service class or not for an entity. You can directly use the resource and call repositories directly, or you can have a service layer in between if you want to do service logic. So I'm going to go with services. Pagination, I'm enabling pagination for certain entities. Similarly, for the product application, I'm defining the entities. And finally, where is it? Yes, and its options, and invoice, and finally, notification. So these are all the entity definition and their relations. As you can see, the relationships are also defined everywhere. So I'm not going to go into details of this. If you're interested, you can download the JDL and you can look through it. If you're familiar with JPA, I think most of you are familiar with JPA, and you would immediately understand what it is. There is nothing special here or new things to learn here. It's the same stuff. Just a slightly different DSL, that's it. And finally, you can also define your deployments. For this application, since I'm going to use Kubernetes, I defined a Kubernetes deployment. You could also define a Docker Compose deployment, or you can do an OpenShift deployment definition and stuff like that. So I defined it as Kubernetes. I mentioned what folders the apps are in. If the folder names are different or something, you can modify those here. The Docker repository to use, I'm using my own. Service discovery type, and the Kubernetes load balancer. What type of Kubernetes service type? You can be ingress, load balancer, node port, or whatever Kubernetes supports for your system. And finally, a namespace, a custom namespace. So this is the application that we are going to do today. So let's get into it. Okay, I think I'm going to go here. I'm going to create a new folder. Okay, I'm going to run JHipster, JDL microservice e-commerce reactive. So this is going to download it from a central repo that I have. So it downloaded the JDL, and can't see much there, it's going so fast. So it's basically scaffolding those applications. It's scaffolding the entities. It's scaffolding the Kubernetes files. So once the scaffolding is done, we'll take a look at some of the files that is generated. And how, okay, I have, okay, some time. And okay, so it's doing an initial NPM build. Of course, the most time that takes is for the NPM to download the world and download everything, like 1 million files, and do the front-end part. That takes the most time. It's so strange, right? The front-end takes more time to build than the back-end these days. So yeah, I think we're almost there. Yes, so I'm going to open this up in VS Code. So as you can see here, this was the file that I downloaded, the same that I showed you there, yeah, with everything. And it created a bunch of folders. So we have our store application. So everything that JHipster does is here. So you have your Java code, just to be sure. So yeah, we have, where is it? Yeah, we have reactive, APIs here. Of course, you have your front-end stuff also for the, where is my front-end stuff? Yes, you have your front-end stuff on the gateway app. So store is our gateway app. And then we have microservice applications like these where, of course, there won't be any front-end, but of course, you have your Java stuff. Very, Spring applications. If you're familiar with Spring Boot applications, these are all Spring Boot applications. So similar structure. We had plans to move to a hexagonal architecture, but hasn't happened for this yet. We also have another project going on, parallel project called JHipster Lite, which is completely built in Java. So JHipster is actually built using JavaScript, though it creates Java applications. JHipster can also create .NET applications, Kotlin applications, JavaScript applications. These are plugins we have for that, but predominantly it was started as something to create Java applications, but written in JavaScript, Node.js application. But a new project called JHipster Lite, which is completely written in Java, is on the works, which produces hexagonal architecture applications. It's more start.spring.spring.io kind of thing, where you just add layers. You run commands to add layers. You don't get everything out of the box. So you create a base, POM thingy. Then if you want, you add cache to it. You run commands to add whatever you need. So it's more of tools that you use to build whatever. And the main JHipster is like it gives you everything, and then you proceed with that kind of thing. Of course, here also we have reactive endpoints. You can see mono endpoints. Of course, everything that JHipster generates is mono because for CRUD, there is no need for Flux, right? Unless you have specific data that has to be Flux. But when you generate stuff with JHipster, everything is by default mono. If you have use cases, you can change them to Flux or whatever. But this is all with mono. So not too interesting stuff to see here. The idea is to show how you can create microservices, reactive microservices using JHipster, and how to integrate authentication into that and stuff like that. So I'm not going to go into the code too much because that will waste a lot of time. Every time I do that, and then end up not having time for the full demo. Okay, so we are here. Okay. Oh yeah, I forgot the Kubernetes part. So since I defined the Kubernetes deployment, it also generated a bunch of manifests for me. So you will have your deployments for every applications, proper Kubernetes deployment with all the best practices like your pod affinity is defined. You have init containers to wait for your databases to start. Everything that you would normally do, you would expect to do in Kubernetes in production. You would have all that. You have your Kubernetes stuff for your Postgres database for this. You have services defined. You have, since I'm using registry, there is Kubernetes stuff for the central config map which you can use to share configuration for all the applications. So if you want to share something to all applications, you put it here, and every application can have access to that configuration, the Spring configuration. And of course, the JHipster registries configuration itself, and everything else is like quite similar. They all have similar configuration, the deployment, the database, and a service definition. For example, notification would have a deployment, MongoDB, and a service definition. You can enable clustering for your applications in Kubernetes. When you define the Kubernetes configuration in the JDL, you can say that, okay, for this application, I want the database to be clustered, just a flag. And then the generator templates will have all the clustering set up for your database configured. So yes, so we have everything ready. One thing to do is the OAuth part. Since we generated this with OIDC for authentication, I haven't set that up yet. So of course, being an Okta employee, I'm going to use Okta. What I need to do here would be, okay, I'm going to go to, no, CD store, yes. I'm going to run Okta. So there is a Okta CLI. So you can download the CLI and you can use the CLI directly to register a trial account or like a developer account, which is free always. You can create a developer account and you can try this out. So I'm going to run this specific command to create a JHipster application, because on Okta, we have configurations to directly create a JHipster application. So it configures everything on the Okta side to work with the JHipster application. So I'm going to run this. Take the defaults. The URLs are all good. It's predefined for JHipster, so the URLs are all good. I'm going to use the redirect URLs, logout redirect URLs, same. And so it's configuring a new OIDC application, and it's going to write down the configuration for me on a file here. If I go here, I should have a new file called Okta-N. So all my stuff is here, a secret. Well, of course, I'm going to delete this app, so don't try to hack into this using this secret. It doesn't matter, it's just a demo account for me. So now we need to pass this configuration to our Kubernetes manifest, so for the OIDC part to work. So I'm going to go to the Kubernetes registry. I don't want to pass this to every application individually, so I'm going to use the config server, which is using Spring config server to easily pass configurations. Where is it? I think not this. Yes, I'm going to put it here. Okay, so I'm pasting in. I pasted in this. So this is for the OIDC part. So I'm using my demo org. So I provided the issuer URI as that. I'm going to take the client ID from this. I'm going to take the client ID and I'm going to put it here. For now, I'm going to take the secret, and I'm going to put it in plain text here. Yes, plain text secrets. I'll show you how to not do that. But for now, I'm going to do that. And OK. 2 more steps, I think. OK, where is my? Yeah. So we did this. Of course, I also have to build and push the images to Docker, which I already done. Again, I don't want to waste time on that, but it's quite simple. These commands are printed when you generate the application at the end. If you look at, if you look here, these commands were all, printed out what you need to do further. So I'm just going to. I already ran, because I already tried this out. I ran and created these applications, and I pushed them to my Docker repo. You could push it to GCR or whatever Docker repository you want. I'm using Jib, which has plugins for Maven and Gradle to make it easier to push Docker images. So I can just from Gradle, with a single command, I can build the Docker images. I can build the application, build the Docker image, and push it to Docker repo. So one command to do it all. I'm using Jib. As you can see here, I'm using Jib for that. So this is already done. I'm not going to do that. And the next step was for the OIDC integration. What I did, as I mentioned, you could use the Okta CLI, run register if you're new. If you already have an account, do login. Then go to the store application, run Okta apps, create JHipster. Then update the registry YML. Yes, I didn't update the registry YML because we also want by default, the JHipster registry uses basic authentication with the username and password. I think the default is admin. But since we are using OIDC, we also want to use OIDC for that. And the JHipster registry, thankfully, is already pre-configured with a profile to do OIDC. I just have to go to the profiles and add OAuth2. I think it's OAuth2, right? Yes, OAuth2. So that's it. This will automatically work with the OIDC configuration I provided. So as simple as that. Of course, there is a lot of magic going on, but that's the point of JHipster. It's like Spring Boot is already doing a lot of magic for you, auto configurations and stuff. So if you're familiar with that and if you're happy with that world, then you will be happy with this, because this does a bunch of more automations, a bunch of more magic for you. That's it. If you're someone who doesn't like magic, if you want to know exactly what's going on, then JHipster is not for you, because there's a lot of magic going on. There's a lot of small things you need, you do and see big difference. Like just put in a profile and voila, you have OIDC authentication on the registry, right? You don't write a single line of code. So you have a lot of these. So if you're not comfortable with that, then yeah. So I'm done that, and so what we did was to set the Spring profile active, which already has prod and Kubernetes in K8s profiles. I also added the OAuth2 profile. This is for registry. This is for the JHipster registry YML. And finally, update the application config map, which I already did. So I already added everything to the config map. And then next, yeah, this is the one. And final step would be go here, cd Kubernetes, yes, and oops. Yeah, cd Kubernetes, kubectl. So again, there is a, I'm going to show you the script. Kubernetes, on the Kubernetes folder, you have a small bash script, which nothing, it doesn't do a lot of, too much magic. It just applies runs a bunch of kubectl apply commands. So it's just an easy command. You can also use customize if you want. There is a configuration for customize and scaffold. So if you want to use scaffold or customize to do further customizations, you can also do that. It comes pre-configured for all that. As you can see, the customization file and the scaffold file underneath. So here, I'm going to run this. It's going to apply all that YAML files, and on the left-hand side, you can see the applications being created. So it's going to take a minute. How long do I have? Anybody? No? Ends at 4, right? 8 minutes. Yes, 8 minutes. Fast, fast, fast. It's always a, yeah. I'm always super optimistic about maybe I'll have time to show a bit more code today, but no, only 45 minutes. Probably I should do this as 3-hour workshops. So then I can go through all the code, explain what's happening, but yeah. But hey, this is for you to, just to show what it is. If you're interested, if you find this nice, if you're intrigued, then you could always go in. I have all the commands on the presentation. I'll share the presentation on my Twitter after this. Probably I'll also pass it down to the folks to share it. Yeah, I'll have some links on the last. We have really nice blog post on the Okta developer blog from Matt and me about these, explaining everything, how to do more secure stuff with it, everything. So you can, if you're interested, you can get into those, and you can see how to do those. So we have almost everything ready. So let's see what our services are. Okay, so we have one load balancer. So since store is our gateway, I mean, JHipster already defined its service as a load balancer, whereas everything else is just cluster IP. So we have an external IP now. First thing would be to add this external IP. I mean, I can do tunneling and just, this should work, but I also want to just go to this IP. And I'm going to, where is this? Yes, I'm going to go to login.okta.com, log into my preview account. Yes. Yes. And come on, I don't have all the time. Oh, no, that's not the, I went to the wrong one. Yes, this one. Yes, and go to admin. I don't need this anymore. Yes, I need to find my application. Yes. So there should be a new application called, where is it? I think this is this one, no. Store, yes. Too many applications, sorry. And I need to add, so this is the Okta application that created when I did the Okta apps create JHipster. So it created everything and configured everything, but I need to update the URL for me to use the URL directly. So I'm going to add, I hope it was HTTP URL. And finally, here, save. Yes. Yes. Now, I can go and access the application, and I should be able to sign in with Okta. And since I'm already signed in, it will just sign me in. It's not going to prompt me to, because single sign-on. So I'm signed in. You can see all the entities here, the customer entity. You can create, edit, delete stuff. So customer is already on store, so no big deal. Product is on a different microservice, and there is nothing yet. So you can go and create test 10. No files. Oops, I didn't create a category, but that's fine. It's not a mandatory field. So I can do all this. So this is calling the microservice APIs and doing its stuff. If you look at the administration screen, you can see, since this is also using the Spring Cloud Gateway, you can see details about the microservices itself. And we also want to see the registry. So let's, before that, we need to encrypt the secret, the plain text secret, right? So the JHipster registry offers a encrypt decrypt endpoint. So because it comes with the entire Spring Cloud config setup. So you can use that to actually encrypt the secrets that you put into the Kubernetes YAML file. So what you need to do is, of course, you need an encrypt key. So basically, I can do UID base64, use this, copy this. So it's a base64 of a UID, and then I go to my registry, and registry, I will add a new. So registry encrypt key. I will do this, and then I need to put in that into, where is it? Nope. Yeah, I need to put this here somewhere. So I added the encrypt key. Is it the same name? Registry encrypt key. Registry encrypt key. No spelling mistakes, right? I often do that. So I added an encrypt key so that we can decrypt, encrypt, and once this is done, I need to actually. I don't think I have time to show the restart part, but I'm going to try just to at least show. So once I update the encrypt key, I just need to run kubectl. I'm going to run it, hoping I will have a few more minutes. Can I take a few more minutes? So it will update the registry. Then I can hit, so I'm going to do a port forward. Is it restarting the registry? Yes, the registry is restarting. I'm going to do a port forward. Come on, registry, start. Yes. Port forwarding and localhost. So this is the registry. It's going to automatically sign in using OIDC. It's signed in using OIDC. And I can go to, so of course, this is a JHipster registry. You can also use console. Then you use console's mechanism to do the, so if you're using console, you probably will use Vault to do the, securely put in secrets. You could also use sealed secrets. For example, there are, I'll put some links on that. Matt has a great article about how to secure your secrets in Kubernetes, for example, because Kubernetes secrets are good, but Kubernetes secrets are nothing but base64 encoded stuff. So you can decode and see what it is. So you don't want those in your repos or whatever, right? So better ways are either to use Vault, use encrypt decrypt is fine, as long as your encrypt key is protected, it's fine, or use Vault or use sealed secrets, a lot of ways. Yeah. So let's go to encryption, and I'm going to copy the value from here, and I'm going to paste it here. I'm going to encrypt it. So I got the encrypted value. The cipher in front of the value is important. That's how Spring config, Cloud config server knows how to decrypt, that this needs to be decrypted when it does its stuff. So I need to put that back here. The codes are also important. What happened? Oops. It's really? Come on. Seriously? Okay, it just decided to hang on me. I don't know why, but now it doesn't save. Yes, okay. My laptop is mad at me for some reason. I don't know why. Again, anyway, I have put in the cipher. Now, do you see something that I don't? No? Okay. Then we go back and we restart again. And it restarts, and then everything should be fine. So now your secrets are not, in plain text anymore. So this is one way to, if you're using Spring Cloud Config, this is one way to protect your secrets using the built-in encrypt decrypt mechanism. And my laptop is acting weird. For some reason, it is quite hot as well. Yes. Something is happening. I can see 97 degrees there, so I can feel it here. So it's hanging up. It's the fastest processor you could find on Intel, but I don't know, something is happening. So I'll figure that out later. Maybe I didn't do a sacrifice to the demo gods today. So it always happens, huh? Anyway, getting back to, yeah, that's how you protect your secrets. And of course, I updated the config map. Voila. We saw the JHipster registry. Did I miss anything that I promised? I think no, that's it. So finally, yes, I promised some more information. Yeah, we saw all this. Yeah, so if you're interested to learn more about this, Matt has a great blog. The first link, it's on the Okta developer blog. You can search for it, or I'll also share this. It's a great blog which basically does the same thing, like reactive microservices on Kubernetes, but Matt has much more details on how to secure stuff with different mechanisms. He explores using seal secrets, Vault, and stuff like that. There's a lot more information there. There's also a blog about how to use Spring Vault, which is a Vault integration for Spring. You can also use that to secure stuff. And I also have a video on YouTube about doing similar with Istio. If you're on Kubernetes, you might as well use Istio instead of having a registry and everything, because Istio also does everything that Consul or registry does. So that's about it, folks. And thank you so much for coming. More information on JHipster here if you're interested, and questions. Thank you. Thank you.